Alright, so when we are talking about doing crypto challenges, just the word itself come from Greek roots. So there is a cryptos meaning hidden or secret. Then there is a word graphene which means writing. So it is literally saying that it is hidden or secret writing. So whenever we are looking at the crypto challenges or whenever you are going to solve some ethical hacking challenges related to cryptography, it is a flag you are sourcing or some sort of data that is secret or hidden from us, and we need to be able to get that somehow. So that is a simple type of crypto challenge that you will see. So that is basically the different encodings that will be available in those challenges. So what I mean by encodings are basically different ways of writing out the actual bits of data. So actual data is hidden by something else. And whenever your actual data, actual, that is the text, is hidden, that means it is a cryptography. So there is a thing called as a cipher text. So let me open here. So see here, you can also get this from the resource section. So initially, let us say my password is something like this, or this is flag also. Let us say this is flag, my password. Now this is the plain password. So I'll just apply some encodings here in this password, some type of cryptography algorithms, and I'll get different password now, something like this. Now you can see this is the representation of this password. Now this is called the cipher text. Cipher, which means hidden, and this is our plain text which is not hidden. Now in our challenges we will be given something like this, which is the cipher text, which is the hidden text, and our goal is to apply some reverse encoding to get the actual text from this, that is cipher text. So that is our challenges. So most cipher text challenges is revolve around this concept. So you can see here I have created some of these cipher text for us to decode, and you can get this from the resource section. You need to download it. So let us start by this first one. So let me copy it, and the thing that we need to use is CyberChef, obviously. Now this is the website that we will be using so often to solve these encoding challenges, because within the challenges our flag will be hidden and we need to decode that flag. Now for that I need to insert it inside the input. Now you can see different type of operations that you can use. Mostly you will be using either from the favorites or from the encryption encoding or from the data format. So these three is the most important. So you won't be going down here ever. Maybe 1-2 cases, but mostly 99% you will only revolve around these three one. Now you can see this looks like encoding, that is the hexadecimal. You can see here ABC word has been used. You can see C has been used, D has been used, and some number combined with it. So that is a hex encoding. So this is a hex data, hexadecimal data. So you need to convert this hexadecimal data into something else. So let us go to the favorite first of all. Here is to hex and from hex. So we have the hex data. So we don't need to convert to the hex, but we need from hex because we already have the hex data. So we will just apply this from hex in our recipe. And you can see the output is this flag. Now this is your flag for the challenges. You solve the challenges now. It is that much easy. So if you do not use this website, which is CyberChef, you need to decode this writing Python code. You need to check each of the instances what this means and convert it into the actual string here. So each of these representation can be easily decoded using this CyberChef website. Now this was the hexadecimal. So remember, whenever the number combination looks something like this, which is combined with ABCD and the numbers, that is usually hexadecimal, because if you remember, hexadecimal starts from 1 to 9 and A to F. So you can see D has been here, and if I have something like till F, then that is the range. That is the range of hexadecimal. So the range of hexadecimal is, let me write here, the range is for the number, it will be 0 to 9 and A to F. Next, you'll see something like this encoding. Let me copy this and let us go here in our CyberChef, and now let me paste it. Now you can see here, whenever we applied from hex, we got output as something like this gibberish, because this is not hex coded. This is not encodings in hex. It is something else. You can see here, we have so many things. Like there is Z also. So whenever you see Z, that is not obviously hex, because the range is outside the hex value. So you will just delete this recipe now. Now this is the input and this is the output, as we haven't applied any encodings or decodings from here. I'm still inside my favorites. So let us just get these favorites, and you can see so many things inside these favorites. So whenever you see the encodings, that is typically ended with this equal sign, and the combination of upper and lower letters, it is usually base 64. Just remember that. You can just know this and you can apply it everywhere. So whenever there is either single equal or double equal, so it is usually done for the padding. So whenever you see this single equal to sign or double equal to sign at the end, and the combination of numbers and letters, then it is obviously base 64. Always remember that. Now it is base 64, so we need from base 64 to something else. So I'll just say from base 64. I'll apply it. Then you can see now this is the flag. Now we applied the decoding from base 64. Always remember, if it ends with equal sign and combination is either from numbers and that is letter, alphabetical letters and number, then this is always base 64. Now let us go to the third one, which is something like this. So now you can see this does not end with equal sign. Now this is not base 64 then. Now whenever you see all in the uppercase, you can see this is all in the capital letter, and the combination is the alphabet and the numbers, it is usually base 32. Remember this. So this is base 64 pattern and this is base 32 pattern. Now base 32 does not end with equal sign. Let us go back, and here I'm going to paste it. Then you can see this is not the base 64, because this does not end with equal sign and this is all in capital letter. So for base 64, it should end with equal sign and the combination of capital and lowercase, but this is all in capital letter. You can see all of these alphabets are in capital, so this should be base 32. Now base 32 is not inside favorites. You need to go inside data formats and search for base 32. Should be somewhere here, base 58, base 32. So from base 32, now you can see you got the flag again. So this is the pattern for base 32. So whenever you see the encodings something like this, just remember there is a base 32. Now we solve this challenge also, which is the base 32 all in caps. Now clearly if you see something like this, then what is this? This should be binary. So let us copy this, and this is obviously binary, clear cut binary. So let me remove this. If you see the combination of 0 and 1, always that is a binary. So I want from binary, because we already have the binary. So from binary we are converting, so we got the flag. So combination of zeros and one, if you see those, that is obviously binary. Next, if you see these numbers, that ranges from uh, the base is from 0 to 10. Whenever there is a base from 0 to 10, so these numbers are not that big, that is near to 150, that is less than 150, then that is the number that is decimal. So whenever you see this type of number, obviously this is not binary because this is not the combination of zeros and one. So you can see the numbers. So these numbers, when the base is 10, they are typically decimal. So let us search for decimal here. So decimal should be somewhere here. From binary, from decimal. So this is decimal. So I'll just drag from decimal into our recipe, and this is the flag. Now you can see this is our decimal. Next case can be when the number is a little bit bigger than decimal. So you can see a number that is relatively bigger than decimal, like near to 150 and above 200 and so on, which is our octal. So in that case, if I put it here, so these are the bigger number than decimal, then if there is a bigger number than decimal, it should be octal. So I'll just go from octal, and this is the flag. This is from octal. So when the numbers are a little bit bigger than the decimal, they are octal, from encoding from octal. So this is octal, this is from decimal, which are all the numbers. You can see all the numbers, but if there is a combination of numbers and alphabetical character, that is obviously going to be hexadecimal. So remember, if ends with equal sign, base 64, all in caps, base 32, clear cut binary if the combination of zeros and 1. If the number is little bit less than 150, near to 150, decimal, bigger number, octal, combination of alphabet and letters are hex. And typically you see these two often used, these two ones. Other are also used, but these two are the frequent one you will see often, base 64 and hex. Just remember these two things, these two ones, and sometimes obviously you need all of them, but these two are the frequent ones.